last video, we talked about how many roots a given polynomial could potentially have. In this video, I want to talk about how we can figure out what the shape of the graph actually looks like, or at least could potentially look like. And this will be very similar to the last video. So we're going to focus on these specific drawings right here where they have their maximum number of roots. Alrighty, so first we're going to take a look at how they are increasing or decreasing. Alrighty, so let's take a look at a linear function. So a linear function, let's pretend is starting with the one that we've drawn here. Now this one starts off negative and then only increases, so it's going upward. And what I'm going to do here is I'm going to create a little table, a new column in our table, and I'm going to say maximum number of directions, I'll say. And what I mean by this is how many is it increasing or decreasing, and how many times does it change. So this one, it only is ever increasing, it never changes because a linear function does not turn back around. So this would be 1. If I look at a parabola now, it starts off by, again, going left to right. It's decreasing until it hits the vertex, and then it's increasing. And so it goes through 2 directions, I'll call it. Alternatively, you could think of it as how many times does it change direction. A linear function never changes direction. A second degree polynomial changes direction once. So it's really just a matter of how you want to think of it. Again, think of a cubic. It starts off increasing, then it must curve back down to hit the second x-intercept, and it has to go back up to hit the third. And so there are 3 directions, or 2 direction changes. Notice, by the way, that if I had flipped it upside down, so if we had a downward facing parabola, like so, it would still be 2 directions, simply starting increasing and then decreasing. Still 1, 2. And likewise for a cubic, it would have just been decreasing, increasing, decreasing. And last but not least, we have our 4th degree polynomial, which goes up, it starts off increasing, then it goes to decreasing, so that's 2 directions. Changes direction again to be increasing, and then back down to decreasing. And so we can see that if there is an nth degree polynomial, the maximum number of directions would be n. So for example, if I had a 6th degree polynomial and a bunch of other stuff, this graph could potentially look like this. 1, 2, 3, 4, 5, 6, like so. 1, 2, 3, 4, 5, 6, like so. Alrighty, so I think that kind of makes sense. Let's move on from there. The second part I want to talk about is how do I figure out which way the graph goes, up or down, and, well, in essence, I'm trying to figure out what's happening at the ends of the graph on the negative end and the positive end. Notice, and we kind of brought this up at the end of the last video as well. When you have an even value of n, the graph starts and ends at the same sign. For example, in this quadratic right here, if the graph starts off positive on the left and you keep going all the way to the right, you will end up positive as well, or you will start negative and then end up negative. Same case with a fourth degree polynomial. You start off negative, you go through your camel humps, and then you end up negative again. Why is that? Well, let's take a look here. Let's look at this example. Okay, say y equals 3x to the fourth plus x cubed minus x squared plus 2. And this is gonna feel familiar based on what we talked about in horizontal asymptotes. Is that when x is really big, and this is what's happening, by the way, right here, x is getting bigger, a big negative number, or a big positive number. When x is a big number, the y value is essentially equal to just 3x to the fourth, because the trailing terms are so small compared to x to the fourth. They're relatively tiny. And notice that if this is really the most significant piece of the function, whether x is positive or negative, these values, when they get raised to the fourth power, will be positive anyway. So 3 times big positive to the fourth is equal to 3 times big negative to the fourth power, because they both can end up being positive. Now, if the coefficient here is negative, then they would both be negative actually. And so whatever this coefficient is, it's going to tell you whether they both end up start and end positive or start and end negative. Let that sink in for a second. We're now going to use the same logic to compare to an odd degree polynomial. So for example, 5x cubed minus 3x squared plus x minus 12. Pretend. Again, when x is big, we are essentially looking at this function, because again, these trailing terms are tiny compared to the leading term. Therefore, well, if x is a big positive, then y itself is equal to a positive number, a big positive as well. But if x is negative, then a negative number raised to the third power is still negative. And so that's why an odd degree polynomial will start off and end in opposite sides, positive, negative, whereas an even degree polynomial will start and end on the same side. So, our big takeaways from this video, our summary of this video. An nth degree polynomial say at most n different, I'll say, sections of increasing, decreasing. So that was just counting the how many times it's going up and down. Another way to think of it, this would be the same way, is that it changes directions. At most, n minus 1 times. Again, n minus 1 because you're not counting the starting directions. On the second part, if n is even, then your polynomial, it starts and ends both positive or both negative. And if it's odd, then they start and end with opposite signs. In the next video, we will discuss, well, actually, we'll also do some practice work on your own first. But we will practice using these to get a pretty fast sketch of a polynomial function. Thank you for watching, and stay spicy, folks.